So there was on 95, this question's about motion, and they gave you the position function of an object. They said it's negative 16 t squared, and then they give you plus v sub 0 t. That's like your initial velocity, and then your initial position of a free-falling object. Okay, so they say a silver dollar is dropped from the top of a building that's 1,362 feet tall. So where would I put that 1,362? Yeah, this last number, they're telling you that's 1,362. So then they're just going to drop a coin from the top of a building, they said. So what do you think the initial velocity is? Yeah, the initial velocity is 0. So determine the position and velocity functions for the coin. Okay, so the position function, we have it. It's negative 16t squared. If you put a 0 in here, 0 times t is 0. So it'll just be plus 1362. So this is the position function. Then they want the velocity function. So the velocity is the derivative of this position function. So you just have to take this s prime of t. You have to take the derivative of this function. That'll give you velocity, the first derivative of this. So the derivative of this, you do that power rule we learned. Take 2 times negative 16, so it'll be negative 32. And then you subtract 1 from the power, so it'll just be t. So it'll just be negative 32t, and then the derivative of 1362 is 0. So it's just negative 32t. Okay, so that's part A, position and velocity functions. So this is the velocity function. Okay, that's part A. Then part B, they want you to find the average velocity. Average velocity. To do average velocity, you plug in numbers. It's kind of like slope. It's like they give you, find the average velocity on the interval 1 to 2. That's like time 1 and time 2. So you have to do the difference in, remember it was like change in position over change in time for average velocity. So you're going to figure out, you're going to take these numbers and plug them into the position function. You're going to plug in like s of 2, plug it into the position function up here, plug in 2. So it'll be s of 2 minus s of 1 over time, change in time, 2 minus 1. Change in position over change in time to find average velocity. So it's because it says average. So if it says average, you don't use this velocity function. You just go plug it into the position function and just do an average. What's the difference between plugging in s of 2 and s of 1 over 2 minus 1? So you got to plug those numbers in.
Please pardon this interruption. We just want to let you guys know that we do know that the internet is kind of still being a little bit spotty. We were informed that it's a Fibercom issue and they are working on it. So just please.
Yeah, it's a little more than spotty, huh? Okay, so you plug in s of 2, and I got, if I did it right, I got 1298. And then you plug in s of 1, and I got 1346 over 2 minus 1. So you're just figuring out the math on that. So 1298 minus 1346. So I got negative 48 over 1. So it's negative 48 for the average velocity. And we can label it because I think they gave us they gave us feet. They said you're up at 1362 feet, so it's feet per second times in seconds. So that's your average velocity, negative 48 feet per second. Okay, then it says for part C, find the instantaneous velocity. So when it says instantaneous, then you use the velocity function. Then you use this derivative function. Then you use that s prime function, the velocity function, which said it was negative 32t. If they want instantaneous velocity, use the derivative function. And they gave you numbers to plug into that too. Find the instantaneous velocities when t is 1 and t is 2. So when t is 1, what do you get? Yeah, you get negative 32. What if when t is 2, what do you get? Yep, negative 64 feet per second. There we go. Yeah, so instantaneous is different than average. Instantaneous, you use the derivative function. Okay, then find the time required, part D, find the time required for the coin to reach the ground level. Okay, do you think ground level is a position or a velocity? Yeah, ground level. If you're on the ground, you're not up high in the air, you're like at level 0. You're like ground 0. You've heard of that before, right? So it said, find the time required for the coin to reach ground level. So that's a position, so you're going to take this function and equal it to 0. They want ground when you're at level 0 for your position. So you take this function and equal it to 0. So we have negative 16t squared plus 1362 equals 0. Yep, find the time required for the coin to reach ground level. So you could just, I would just solve this. I mean, some people try to factor it. I would just solve by taking square root. Like I would subtract 1362. Then divide by negative 16. Then take the square root to get the answer.
Could you go up just for a second?
Oh, like so you can see the top ones?
Yeah, the velocity.
Yeah, it's the derivative of this.
Oh, so the velocity function is the derivative of the position function.
Mm-hmm.
Yeah, okay. Thank you.
Yep, velocity is derivative of position. Okay, so now I divide by negative 16 on this one. So I got negative 1362 divided by negative 16. And then you have to take the square root of that. So I got like 85.125. So then I have to take square root of that to get the answer finally. Square root of that. I got 9.226. Let's round it off. So that's the time it takes for the coin to reach the ground. It's dropped off a building. Then find the velocity of the coin at impact. That's how long it takes to hit the ground, right? So that's like when it would take 9 seconds for it to hit the ground. That's impact, when it hits the ground. So find the velocity of the coin at impact. So then you're going to take this number from part D and plug it in back into the velocity function. Find the velocity at impact. So then we'll plug this in to the velocity function, negative 32t. Negative 32 times this 9.226. So our velocity function is the same as the derivative of the position function, negative 32t. So yeah, plug this into there, and so we'll find the velocity at impact after 9 seconds. We'll find the velocity. So negative 32 times 9.226. It's like about negative 295, and then it has a decimal, like mine says negative 295.232. Yeah, so there's a lot of parts to these. I know it takes a while to like figure them out. So that was 95. Is there another one you want to go over? 98? Okay. This one's a rock is dropped from the edge of a cliff. That's 214 meters above the water. Yep, so 98. A rock is dropped from the edge of a cliff. That's 214 above the water. Okay, so again at the top on number 98 in the directions, they gave you a function to use. And I think this is in meters. Yep, so it's a different number. It has negative 4.9 t squared plus initial velocity times time plus initial position. Okay, so this one says the rock is dropped from a cliff that's 214 meters above the water. So you'd put 214 for the starting position. Determine the position and velocity functions for the rock. Yeah, so again, they're just like going to drop a rock from the top of a cliff. So your initial velocity is 0. Because they haven't dropped it yet. You know, like when you start, it's not moving right at the beginning. So your position function is negative 4.9 t squared plus 214. So then our velocity function is the derivative of this position function. So it'd be negative 9.8 t. So that's your position and your velocity functions. Determine the average velocity on the interval 2 to 5. Okay, so then they want average velocity from the interval 2 to 5. So when you do an average, you use this position function. And you plug in s of 5 minus s of 2 over 5 minus 2 to find the average velocity. So we're going to have to plug in 5 into this position function. Negative 4.9 times 5 squared plus 214. So I got like 91.5. And then negative 4.9 times 2 squared. See, I'm just trying to plug the numbers in. Plus 214. I got 194.4. And 5 minus 2 is 3, so I'll divide by 3 at the end. If that's not what you get, or you think I did want something wrong, let me know, because I am just doing, just doing it right here in class, and if I mess up sometimes too, so just let me know if you think I messed up. So I subtract this, I got negative 102.9, then I divide by 3, I got negative 34.3 for the average velocity. That'd be meters per second. Okay, then find the instantaneous velocities at time equals 2 and time equals 5. So now it says instantaneous velocity, so then you try it in the velocity function. So try to do, plug in 2 into this derivative function. So negative 9.8 times 2 is negative 19.6, and then try 5 in there. Negative 9.8 times 5. And that gave me negative 49 meters per second, meters per second. Try to label things. There. So this one was an average. See, this one's an average velocity, and then this was the velocity at each of those points, that individual points they gave you. Instantaneous velocity at 2, instantaneous velocity at 5. But this is just an average. Okay, and then find the time required for the rock to reach the surface of the water. What would you do for that one? Find the time for the rock to reach the surface of the water.
You said equal to 0.
Yeah, which of those equations above would you set equal to 0?
The position.
Yeah, the position function. When is the position at, just like at level 0? That's right, good job. So you take that s of t function. When does that equal surface of the water? So like when would that equal 0? So you can just subtract 214, divide by negative 4.9, and then take the square root of that to get the answer. So square root of that answer. And then you can round it off. I got about 6.609 or 6.61 or something like that. You know, it just said round it off. Find the time for the rock to fall till it hits the ground. You know, that's why it's equal to 0. And then finally, part E, find the velocity of the rocket impact. So then plug this number into the velocity function. So it'd be negative 9.8 times this number, times this 6.609, times negative 9.8. So you get about negative 64 point. Your rounding might be a little different than mine, but if you're close, it's fine. 76. Like comes out to about negative 64.7 or 0.76 meters per second. That's like the speed at impact, the velocity at impact. Well, the speed would be positive 64 meters per second. Because remember we also said speed is the absolute value of the velocity. The negative on the velocity means that, you know, it's like falling, going down. So the speed would be positive 64.76 meters per second.
I think you already answered this, but how did it get to be negative 4.9 t squared, or just like?
Oh, so it was in our notes, the gravity.
Oh, it's, okay.
It's like a free-falling object. It had a formula. Let me find it in our notes. Negative 1/2 times g for gravity, and the gravity number is 9.8 meters per second, and it was negative 1/2. Yeah, it's just given to you because it's negative 1/2 times 9.8 meters per second for gravity. That's like falling due to gravity.
That makes sense.
Mm-hmm.